2D trellis plots of groups are graphs that enable you to explore very large data sets in which observations are classified into groups. This graph type lets you investigate the distribution of groups of observations over 2 dimensions, that is, 2 variates, using either a trellis of bar charts or a trellis of pie charts. The graph is created by gridding the data in the XY plane, then forming either a bar chart or pie chart from the data points that fall within each grid box. Let's use one of GenStat's example data sets to see how this works. This data set contains morphometric measurements of size and shape information on over 13,000 beans from 7 different species. We'll explore the distribution of bean species over shape factors 1 and 2. First, open the 2D trellis plot of groups menu. On the y-axis, we'll plot shape factor 1, and on the x-axis, shape factor 2. Our grouping factor is bean type, which gives us the species of each bean. Click the Options tab and enter a graph title. In the Plot Type section, select the trellis plots you want to create. I'll select all 3 so that we can compare them. Display Key will insert a key showing the group's names and colours under the graph. Leave this selected. The Colours for Groups section lets you set group colours for the segments in a pie chart or bars in a bar chart that represent each species of bean. You can review the colours by selecting a group in the drop-down list and change the colour by selecting a different one. The key height field controls the height of the key. Because we have 7 bean species, we'll need to increase the height from the default of 0.1 to ensure there is enough space to display all the labels in our key. You can set the height from 0.1 all the way up to 0.5, but as I've already tested this out, I found that 0.2 is big enough to hold all our labels. When you plot a trellis of pie charts, the amount of white space around each pie is controlled using the pie chart margins field. Setting this to 0 gives you no white space between the pie charts, while setting it to a large value gives you a lot of white space. We'll leave this set to the default of 100. The next field, Size for Labels, controls the size of labels on pie charts. These labels show the number of observations within each pie chart. If you set the size to 0, your labels will have 0 size. They simply won't appear. Changing this setting to 2 creates labels that are 2 times larger than the default. We'll leave this value at 1. The grid used to partition the data into the individual bar or pie charts is controlled using the number of partitions and the axis scaling. Number of partitions lets you change the number of grid partitions along the x and y axes. The default setting of 8 divides both the x and y axes into 8 partitions, creating an 8 by 8 grid, which gives us a 64-panel trellis plot. Setting the number of grid partitions to 3 creates a 3 by 3 grid, giving us a trellis plot with just 9 panels. We'll leave this at the default setting of 8. The Equal Axes radio buttons control how the partitions on the x and y axes are made, either independently of one another, using the same axis scaling, or using the same axes bounds. We'll select No to scale the axes independently. Finally, as is typical of a GenStat graphic menu, there are x-axis and y-axis tabs where we can set various axes attributes. We'll leave all these settings at their defaults. But remember, if you need to know more about any of these settings, just click the Help button. We're now ready to produce our graphs, so click Run. The first graph is a trellis of scaled pie charts in which the area of each pie chart is proportional to the number of observations in that area of the graph. For example, there are more observations in this area of the graph than over here. From this plot, clear differences in the distribution of bean species over shape factor 1 by shape factor 2 are evident. If we look at the Dermison beans, plotted in cyan blue, these tend to appear in the top right corner, whereas Bombay beans, plotted in green, tend to appear in the bottom left corner. If we go back one chart, we can see our unscaled pie charts. These number labels show the number of observations each pie chart represents. Click back one more time, and here's the bar chart version of this data. In addition to performing exploratory data analysis, these types of graphs are especially useful following a multivariate classification analysis, such as canonical variates analysis, discriminant analysis, and stepwise discriminant analysis for exploring how effective the analysis has been at separating the observations into their respective groups. Let's see this in action as we perform a canonical variates analysis on the bean data. To use all the morphometric variables in the canonical variates analysis, scroll to the bottom of the available data field. Now, hold down the Shift key and click the last variable in this list to select them all. Click the arrow to move them into the Data to be analysed field. Put the cursor into Grouping Factor to give it focus, then double-click Bean Type to make this the grouping factor. After we click Run, and the canonical variates analysis is performed, the Trellis button becomes active, giving us the option of creating a 2D trellis plot of groups from the results. Let's create a trellis of unscaled pie charts. Set key height to 0.2, then click Run. And this looks like a good result. From this graph, we can see the first two dimensions of the canonical variates analysis are doing a reasonably good job of separating the 7 bean species. If you want to learn more about canonical variates analysis, you'll find lots more information and example analyses in Chapter 3 of GenStat's Multivariate Analysis Guide.